What's going on, guys? A little late for Facebook, but we're going to keep it moving. We're going to talk about a little science today about the importance of the woman in nation building, epigenetics. Who knew about epigenetics? Hey, press the thumbs up, share this on your social media for me. We'll get started real quick and soon. All right. Like I said before, really, we're going to do this fairly quick. Just wanted to make this point. I was talking to my brother BMT. We was talking to brother Trey by NBD, I believe, and Hood Conservative. And we were just talking about some various topics. And a lot of times with those topics, it goes over there to that gender war stuff, which I don't like. But then it becomes into the defense of women. And there's a lot of YouTube universe people who thinks it's what they call lame or stupid for men. You're supposed to treat women just like men, which is absolutely insane to me. But this is what a lot of people really believe. And we need to understand the difference. There's a reason why people have different temperaments. Generally, males have different temperaments than the females. Generally, now both sides, as we know, can emulate each other. So men can act like women, and women can act like men, but it's not natural. It's not normal, and it does not serve the particular group. And we have to understand that this is group unity and group operation talk here. So if you're not into unity and group operation talk, of course you're going to be like, that's stupid, that's lame, ain't nobody trying to work with that. But this is what any successful, powerful group is going to have. They got to have a degree of collectivism. The collectivism does not annihilate the individual importance, because we have the ability to act as individuals, but we are way more powerful, as every other successful group on this planet will show you. A human population is way more powerful as a collective. So if you know how to operate as a group, you know how to get resources and organize and distribute your resources as a group, and you know how to think of the future of the group, the future success of the group based upon the history and the past of that particular group, then you're going to be way more smarter. You're going to be more powerful. You're going to be able to do far more things. Now, the people who want to stick up in these individualistic type mindsets, a lot of these people, they just want to, because they had a bad experience with the opposite sex, they want to, be hateful on the opposite sex. They want to argue with everybody else. They want to continue on this gender warfare. And really this stuff, this so-called, they call it women's lib, and it probably was women's liberation, but really black people was getting liberated from the enslavement process in America. Okay, so we can't forget, we can't pretend that we ignore any facts, any factual realities. It's not intelligent for any science-based or fact-based approach to ignore that if you're trying to find actual answers. So we're going to go into a little bit about this thing about epigenetics. I want to share the screen. I want to get into the fair use doctrine. Let's see if I can even get to the point of fair use. And like I said before, if you're on YouTube, go ahead and press the thumbs up. If you're on Twitch, go ahead and make a comment, share the stream to your social media. If you're on Facebook, make a comment, let me know what's going on. And hold on one second here while I go ahead and I'm going to do this. And I'm going to do this. Let me use. Doing that while I find my fair use, guys. So that's the fair use. So whatever we share here, I just want y'all to know, want the YouTube Universe censorship team to know that I'm actually sharing this in hopes of teaching, educating, and, you know, we're going to share some information. And I want the people to actually see and understand what's going on. So that's what this is going to be for. So let's do this. And then let's redo this. Let's see if we can get it back. All right, hold on a second. There's a couple of parts in here I want to share. So we're talking about epigenetics, and just in a nutshell, the epigenetics, you have your genes, which code your proteins to make all the various parts of your body, your hair. Also, it makes it's the genetic blueprint that your parents have combined together to give you, so that you're able to organize your proteins to build the various portions of your body. Some of those genes are active. For example, all of your cells have every gene to build your entire body, but some of those genes are on and some of those genes are turned off. And this epigenetic issue, it speaks to, you know, how nature, how God basically has decided to turn some of those genes on and some of those genes off. And it actually goes deeper than what builds. It also kind of factors into behaviors, you know, based upon some of the situations. So let's just look at this here. Let's see if we can explain this.
And like scientists do, he told me about his work.
And he told me that he is interested
in how mother rats licked their pups after they were born. And I was sitting there and saying, this is where my tax dollars are wasted on this kind of soft science.
All right, and so I just want to point out a point that we might have missed. He said he's researching how mother, not father, he's researching how mother rats lick their pups. And this, in human terminology, it translates into caring for their offspring. How do they care for their children?
And he told me that he is interested in how mother rats licked their pups after they were born. And I was sitting there and saying, this is where my tax dollars are wasted, on this kind of soft science. But as the beer got more intense and the alcohol gets into the brain, you become more receptive. And he started telling me that when the rats, like humans, lick their pups in very different ways. Some mothers...
And for anybody who looks at this and say, well, I'm not a rat, you got to realize that they study rats. Why? Because they know for a fact that there are several analogous behavior patterns that they can determine based upon their study from things like humanized mice and rats, monkeys, and other animals to humans. This is the only reason why they study them. They're studying them to understand better how these kind of experiments or these kind of stimuluses can affect humans. So don't get into this mindset, well, I'm not a rat. Of course you're not a rat, but guess what? Some of this stuff can affect you.
Do a lot of that. Some mothers do very little, and most are in between. But what's interesting about it is that when he follows these pups when they become adults, like years in human life, long after their mother died, they are completely different animals. The animals that were licked and groomed heavily, the high licking and grooming, are not stressed. They have different sexual behavior.
So listen to that. Now think about humans. Groups of the rats. He's talking about rats, but just imagine if you're a human being and you had a mother that cared for you, you're going to have different stress levels throughout your life. You know, the way you handle stress, even the sexual patterns become different. This is how they study people.
They have a different way of living than those that were not treated as intensively by her mother. So then I was thinking to myself, is this magic? How does this work? I'm a biochemist. I believe that there are chemical explanations to nature. I was working in a field called epigenetics. But before I jumped into that conclusion, we had to do another experiment. Is this genetic, as geneticists would like you to think? Perhaps the mother had the bad mother gene that caused her pups to be stressful, and then it was passed from generation to generation. It's all determined by genetics? Or is it possible that something else is going on here? So in rats, we can ask this question and answer it. So what we did is a cross-fostering experiment. You essentially separate the litter, the babies of this rat at birth, to two kinds of fostering mothers. Not the real mothers, but the mothers that will take care of them. High-licking mothers and low-licking mothers. And they do the opposite with the low-licking pups. And the remarkable answer was, it wasn't important what the gene you got from your mother. It was not the biological mother that defined this property of these rats. It is the mother that took care of the pups. So how can this work? And as I told you, I'm an epigeneticist. I'm interested in how genes are marked by a chemical mark during embryogenesis, during the time we're in the womb of our mothers, and decide which gene will be expressed in what tissue. Different genes are expressed in the brain, and in the liver, and the eye. And we thought, is it possible that the mother is somehow reprogramming
the gene of her offspring through her behavior. And we spent 10 years. And we found that there is a cascade of biochemical events by which the licking and grooming of the mother, the care of the mother, is translated to biochemical signals that go into the nucleus and into the DNA and program it differently.
So I just want us to think about what he just said. The way your parent, this is talking about the mother, because the mother, even in human terms, the mother is very important, because usually the father is out, getting resources and trying to bring those resources back. But it's that mother that's there taking care. The way that mom does that, if she's even there, if she got to go out, that's all totally different. Either you're going to get the care or you're not going to get the care. That's going to turn on certain actual biological genetic responses. And that genetic response will go into you. It may even skip you and go into your kids. The response from your mother, their grandmother, goes into them. That's what they're saying here. This is what they're saying. The response to stress in the environment. Do these kids have high stress, or do they have parents that can shield them from some of that kind of stress? You see, and now let's go on a little further with this one, and then we'll go to the reading material, and then we'll get out of here. This is just going to be fairly quick.
So now the animal can prepare itself for life. Is life going to be harsh? Is it going to be a lot of food? Are there going to be a lot of cats and snakes around? Or will I live in an upper-class neighborhood where all I have to do is behave well and proper, and that will gain me social acceptance?
You see, social acceptance. You see how he's translating the animal situation into the human terminology. So are you going to grow up in the hood, ghetto, where you get shot all the time, or you got all kinds of stress levels? You got police coming around trying to scare you or beat you up. You got gang members trying to kick your butt. Are you going to grow up in that type of environment, or are you going to grow up in an environment where you got help, you got assistance, you got confidence building, these type of things? So this is what they're studying here, how to turn these things on and off. And it literally translates to different chemicals being, the brain developing differently. So let me go a little further, because I want to get to another part that he said. And let's see if we can go to that.
Interesting about social rank is that across all living beings, they will structure themselves by hierarchy. Monkey number 1 is the boss. Monkey number 4 is the peon. And you put 4 monkeys in a cage, there will always be a boss and always be a peon. And what's interesting is that the monkey number 1 is much healthier than monkey number 4. And if you put them in a cage, monkey number 1 will not eat as much. Monkey number 4 will eat as much. And what you see.
Now listen to that part. Now you got to think, this is translated into humans. They know what the boss, they know the chemical difference, the chemical, biological, genetic, epigenetic difference between the boss and the peon, and the alpha and the beta, or the basically the zeta. Okay, so there is a biological chemical signature to that, and that can be programmed through this processes that they're finding out. Once you understand something, you can control it to a degree. So, and he gave you some hints. He said the healthier monkey is going to eat a little less. The peon is going to be a fat slob, basically what he said. Let's listen to that part again.
A boss and always be a peon. All living beings, they will structure themselves by hierarchy. Monkey number 1 is the boss. Monkey number 4 is the peon. And you put 4 monkeys in a cage, There will always be a boss and always be a peon. And what's interesting is that the monkey number 1 is much healthier than monkey number 4. And if you put them in a cage, monkey number 1 will not eat as much. Monkey number 4 will eat as much. And what you see here in this methylation map.
So what I want y'all to say too, now this is the way that these genes get turned on and off through this process they call methylation. Methylated and demethylated. Okay, this is how there's a gene that exists there, but it doesn't do anything unless it has certain signatures on above it. That's called the epigenetic code. So you can have a genetic code that's full of all kinds of things that they're just sitting there. That's where they used to get the term junk DNA from. But if it has methylation codes on it, those genes will get expression. They will be unwinded. Because everything is in a tight pack, and if it's too compacted together, it can't get expressed. The proteins, the ribosomes can't synthesize that genetic code into a protein. So the body basically has a process to kind of stretch it out so that it can be read. Okay, so this is just a little bit of knowledge on epigenetics. I just want us to go study that a little bit more because, of course, we can't go into the whole thing because it's a big science, but this is something we should understand. And this is something when scientists are talking about, oh, well, African Americans, they're, systematically the most sick. They always have sicknesses, disparaging, they're always sick. They're always sick. They're calling you a peon, basically. You always sick. Is that true? Or is it, shouldn't we want to get away from that? Or shouldn't people, but that's also a low-key way of keeping a certain group as a subordinate. And that should be understood. So let's look at this here. Let's want to read this other part, and then we will be moving on. Because right here, I just want to get this. This is the B1 MSH channel, Math, Science, and History channel. And we want to just introduce some topics, stuff that people might not have paid attention to. Let's see if I can get, I think it's this one. Yeah. So, and you got to realize, so in human terms, if you have a population, where the females have had to fend for themselves for a few hundred years, they had to be a little bit more aggressive. They had to go out, earn the money, and bring it back. And they had to rear their children or whatever it was. You're going to have a situation where those women are going to be a little bit more aggressive. Maybe they'll have a little bit higher testosterone number. This is what you got. You will see that in certain communities, especially Black people, Americans. And so, and even in any group of people that has literally hundreds of years, even decades, even multiple decades of stressful situations that's going on in that family, you're going to see some of these more aggressive behaviors. This is just normal, natural for any group of people. And the conversation that I had earlier with a young brother, the big deal was about some of these women having this masculine demeanor. And here's your answer. The conditions, the human or all life is going to adjust to the conditions that it grows in. And so that's what's probably going on there. So let's read some of this here. Epigenetics and female reproductive aging. with more women than ever waiting until a more advanced age to have children, there exists a newfound urgency to identify the various implications aging has on human reproduction and understand the disrupted biological processes that result in these changes. In this review, we focus on one recent area of study, the age related epigenetic changes that have been found in female reproductive organs. Epigenetic changes that have been found in female reproductive organs, and the effect of these changes may contribute to reproductive outcomes. So, your background. As a result of many social economic factors, as I talked about earlier, increasing numbers of women are delaying childbirth until a more advanced age. Increasing maternal age has resulted in well-documented decreases in fertility. The increase in oocyte aneuploidity, let's see if I can get a quick definition of that word because I don't know it. Okay, let's see. Aneuploidity. Let's see if I got that. And aneuploidity is the presence of one or more extra chromosomes or absence of one or more chromosomes. The risk of fetal aneuploidity rises with increasing maternal age. So the older the mom is, the more risk of this issue, because fetal aneuploidity can affect any pregnancy. All pregnant women should be offered screening. All right, so that's what that is. And so the increasing oocyte aneuploidity and pregnancy complications, while these risks are clear, the underlying psychological processes that result in these outcomes are much less well defined. Proposed mechanisms involve neuroendocrine deficiency, oocyte chromosome telomere length, meiosis abnormalities, mitochondrial dysfunction, as well as epigenetic modifications. Here, we discuss the epigenetic alterations associated with aging in female reproduction and their effects on female reproduction. Okay? I just use that over and over again. Epigenetics, a general overview. Epigenetics are heritable covalent modifications to DNA bases and chromatin proteins that do not alter the actual base pair. So your actual base or your actual dominant or recessive base pair. And those base pairs, they have 4 of them: guanine, uracil, I forgot the other, thymine, and cytosine. So those base pairs are not altered the way that they're organized. So it's a chain. We know that DNA chain. So those are not altered, but rather enhance or repress its transcription. So the transcription are they able to be expressed in life? Are they able to be used, basically, by affecting chromatin structure and transcription factor binding? Epigenetics are essential to normal development and function and play an integral role in both normal cellular function and disease. Epigenetic modifications include DNA methylation, histone modification, and chromatin remodeling. So those are things that you would look up if you're interested in this more. And basically, this particular document is focusing on because of the social status that we have going on with the increasing pressure on women to go out and earn the money and earn their keep. They have to do more masculine things, and so they are, putting off on having children. They kill the kid, they have the abortion early so they can make some money. And then later on, when the biological clock is ticking and they feeling alone, nobody there, they didn't have no kids yet, then they make a mad dash trying to have their kids, right? And this behavior, this process is actually changing the way the DNA is expressed. It's changing the way the DNA is expressed because the behavior is changing. This is how what you call this is the foundation of what they call survival of the fittest, or what they call that Darwin's thing. But Darwin's thing is not the only way genes get altered and different folks get expressed. So let me go through this here real quick. During normal development, I'm just skipping through here because I'm really trying to get to a more interesting part here. Let me see. With aging pattern of. So they're going through mice again, DNA methylation, alteration, reproductive aging. All right. Let's see, he's talking about aging, summary, and conclusion. Let's look at what they concluded, and then we'll be done with this, and we'll be done with the stream. Now, like I said, if you want to get more detail in this, I'm going to leave this here in the chat for you guys. I'll leave this here in this chat, and folks can go in here and check it out, or you can just pull up this article. So you can just pull up the article as well yourself. But let's finish this. Let's just see what the summary was. Oh, hold on. 1 second here. All right. In summary, the existing work on epigenetics and female reproductive aging sheds light on some more important cellular mechanisms while raising many more questions. Manipulating DNMT or HDAC levels. And we would have to go look those up. Otherwise, we wouldn't be able to understand what's going on. But these are levels in mouse oocytes. And I know oocytes are the ovarian cells. This leads to morbid outcomes. Morbid means death. So that's not good. Illustrating the critical role these enzymes and epigenetics in general play in normal development. A better understanding of their function in normal development and how they are affected by aging may lend valuable insight into reproduction and reproductive aging. MII oocytes implantation embryos of aged mice show a decrease in DNMT enzymes and methylation levels. Aged mouse oocytes also show an increase in demethylation enzymes and demethylation cascade intermediates. In contrast, human granulosal cells showed a more nuanced change in methylation with advanced age, shifting towards either extreme increased methylation in highly methylated, and methylated means areas that are highly expressed. Okay, and that's just a simplification of it, but you can go into that a little bit more so you can get a better understanding of what they mean by methylated. But this is the on and off, basically, to these genes. Methylated regions and decreased methylation in poorly methylated regions. Histone acetylation was paradoxically decreased in GV oocytes, but increased in MII oocytes of aged mice in humans as compared to young mice. They were shown to play a critical role in normal meiosis. Meiosis is the division of the sex cells, with meaning the sperm or the ova, once the meiosis after they've been fertilized, and were also responsive to corrective measures. Finally, histone methylation is decreased in GV ovocytes of old mice. Little has been published thus far on the changes of histone phosphorylation, ubiquination, and semoilization. Those sound like a bunch of word salad, but we would have to define each one of those words. Or the changes to non-histone protein modification in oocytes with aging and the consequences those changes may carry. Histone simulation, for example, plays a critical role in mitotic regulation and spindle assembly in oocytes. Epigenetic modifications disrupting normal histone semoilization functioning can theoretically have severe deleterious effects. Further research is necessary to better understand these changes, and more specifically as they occur in human oocytes. It is also critical to better understand mechanisms of epigenetic change with age and the factors that may mitigate or accelerate them. Can biologic or environmental elements that produce oxidative stress, which has been shown to disrupt cellular epigenetics, be a factor in determining reproductive longevity? Would it be possible to impede this process or even correct it, as has been done experimentally using TSA to correct for abnormal acetylation levels? Finally, can epigenetic modifications in human oocytes be used to predict an oocyte embryonic development potential? So basically right there, what they're saying is, can they modify humans to make a superhuman? Or can they say, oh, this is going to be a real smart person, or this person is going to be absolutely stupid? So can that be used to predict oocyte embryonic development potential, or will it even develop at all? These questions are just a few of many important areas for clarification and carry the potential of improving and fundamentally changing the care of millions of women around the world need to receive. So that's that. They said that the authors declared that the research was conducted in the absence of any commercial or financial relationship that can be construed as potential conflict of interest. And so pretty much, like I said before, this is just to introduce that to us. This is to let us know that, science is very important. They're using science on us. We all have science, the type of science that is affecting, the way humans develop. It's translated into our behavior patterns. It's just going everywhere. So we got to start to understand the science, because even with the chemicals that's in the water, in the food, when you read the back of that Frito-Lay's bag, that Cheetos bag, that Crunch Berry box, Captain Crunch Berries, what are those chemicals doing to you? What are those chemicals doing to your childbearing cells And as far as behavior patterns, if you have women going out getting the same developing the same aggression as men to go out and get money and resources and everything to that effect, who's teaching the children, who's caring for the kids? Are the men there to protect anybody, or are the men to help to keep the home stable? Are they there? Do the men feel responsible? Are the men becoming more feminized because they're used to being chased now? The men want flowers and they want to be bought a new car with a bow on it. And the men want to be proposed for marriage. Is that what we see going on nowadays? Are we seeing all the gender roles be replaced? A variety of genders and all sorts of ideas that's being flared around. So it's not all on epigenetics, but it's a big part, guys. So we just need to pay attention to that. We need to look at the science behind this stuff. We need to understand that once we have awareness of this, we are in control. All right, peace.